The title of this video is Inconvenient Data, a new analysis of climate change that's based on actual data. There's a companion book that goes along with this available from Amazon, and I'll say a little bit more about that book at the end of this video. So by now, we've all heard that a consensus of scientists agree that a climate catastrophe is just around the corner. All of these horrible things are going to happen. This is all being caused by CO2, and humans could stop all the bad things from happening by reducing the amount of CO2 in the atmosphere. But an important question is any of this actually true? So in this study, we're going to take a look at measured temperature data for the global climate, and we're going to see if that data can tell us anything that might lead to an answer to that question. Well, it's interesting to note that the consensus of scientists don't base their predictions on actual data, but rather on computer simulations. And there are several things that it's important to realize about computer simulations, the first of which is that they do not provide evidence. They simply produce whatever output they are programmed to produce. But a really big item here is that these consensus of scientists' computer simulations do not actually simulate the climate of planet Earth. They simulate the climate of a mythical planet that I call Mythos. Now, Mythos is exactly the same, identical to the Earth, except it has one major difference, and that is that on Mythos, there is no natural climate change. On Mythos, all climate change is caused by CO2 in the atmosphere. Well, that's inconvenient because on Earth, we know that the climate change here is caused both by a combination of natural forces as well as by CO2. Well, it turns out that we don't actually need to simulate the climate of planet Earth because we have actual measured global temperature data. The Hadley Climate Research Unit in the University of East Anglia in the United Kingdom has maintained and is maintaining monthly global temperature data from 1850 up to last month. The HADCRUT 4 global temperature data set is the one that I'm going to use in this study. The purpose of this study is to analyze these measured data and to determine whether they can tell us anything about the future of climate change here on Earth. So this is a plot of the Hadley data. There are going to be lots of graphs and charts in this presentation, so I want to just make it clear at the beginning that on all of these charts, the horizontal axis represents years and the vertical axis represents temperature. So all of the plots show how the temperature has been varying as a function of time. Well, you can look at this data and you can see it's obvious. There's no disputing the fact that the climate has been warming recently. There also is no question of doubt that 2015 or 2016 will be the hottest year on record, but that is largely due to the big temperature spike that occurred because of the El Nino that happened in those years. Well, you can look at the temperature data and you can see that in general it's been getting warmer here on Earth, but it hasn't been getting warm in a uniform, consistent pattern. Sometimes the climate was warming. To 1910 it was cooling. To 1945 it was warming. To 1975 it was cooling. And to 1998 it was warming again. Now since 1998 we've been experiencing a gradual cooling trend with the exception of the El Nino event in 2015. So when a data analyst sees a pattern like this of oscillating up and down and up and down and up and down, the first thing that might come to the analyst's mind is, I wonder if there are any periodic oscillations in this data. So that's what I did is, this question is so common that there are actually canned computer optimization routines that are used to analyze, settle this type of question. So what I did was to take the measured Hadley temperature data, fed it into these standard computer optimization routines with the question, do the data contain any periodic oscillations? The output of these standard optimization routines was, as a matter of fact, yes, the data do contain oscillations. In fact, they contain 5 periodic oscillations, 5 different periods, 5 different amplitudes. And when you add all of those periods and amplitudes together, you get a graph like the red curve here. So I call this red line the 5-period preliminary cyclic model. The reason it's preliminary is you can see that prior to mid-20th century, this model matched the temperature data extremely well. But after mid-20th century, the measured temperatures were increasing faster than the model would indicate. So when we get a difference between the actual measured data and the model, we know that there's something missing from the model. There's another component that we need to make the model better match the measured data. Well, it turns out that that additional climate component looks like this red line. It's a linear trend that starts in 1955 and continues upward at a rate of 0.37 degrees centigrade per century. So this is the best fit model to the difference between the measured temperature data and the preliminary cyclic model. Well, this is very interesting because a linear trend such as this one is exactly what the climatologist would expect the results of CO2-caused warming to be. Global warming will show up as a linear trend in the measured temperatures. However, it's also interesting to note that the additional warming that might be caused by CO2 is only 0.37 degrees centigrade per century. This is an incredibly tiny effect due to CO2. In fact, the total warming from 1850 to 2015 that may have been caused by CO2 is only about 0.2 degrees centigrade. So when you take this linear trend component and add it to the preliminary cyclic model, we come up with what I call the final cyclic climate model. And as you can see here, it matches every significant climate variation in the past century. Actually, it measures every significant climate variation for the past 165 years. Well, that's great. We've got a model now that matches temperature data that we already knew about. But that's not really what we want. What we want is a model that can help us predict future temperatures. So I created what I call a 1965 validation model. And this model is exactly, it was created in exactly the same way that the 2015 model that I've just shown you was created. The only difference is that this model only had measured temperature data from 1850 up to 1965. So as far as this model is concerned, everything that happened after 1965 is unknown. It's in the future as far as that model is concerned. So the question is, how well did that 50-year-old model perform in predicting what we know has happened in the succeeding 50 years? And the answer again is it predicted what we know has happened incredibly well, very, very well. In fact, there's very little difference between the model created using all of the data all the way 1850 to 2015 and the 1965 model that only had access to data from 1850 up to 1965. And both of those models predict essentially the same future temperatures. This is kind of astounding. What this means is that climatologists could have analyzed the data 50 years ago in 1965, and they could have predicted today's temperatures with an accuracy of about 0.1 or 0.2 degrees centigrade. So there's really no reason to suspect that the periodic oscillations that fit the data so well in the 50 years since 1965 won't also fit the data that is yet to occur in the future. I put a star by the title of this slide because it's astounding. The climate is not a chaotic random process as has been thought. Climatologists have long believed that the climate is a chaotic process. Chaotic processes are random and they are not predictable. But we've just seen that it's possible to predict how the climate has changed in the past 50 years based on information that we had before that. So this analysis of real data proves otherwise. In fact, it looks like the climate has been following a series of periodic cyclic oscillations for at least the past 165 years. These cyclic processes are both computable and predictable. I mean, this is sad for the climatologists because rather than using supercomputers and sophisticated simulation programs, you could actually calculate average global temperatures for any year from 1850 up till now. You could compute those using the calculator app on your cell phone. Okay, well, if we think that the cyclic climate model can predict the future, what are those predictions? So I've expanded the scales here so that the distance between 2015 and 2100 has been occupies most of the chart. So the red line is once again the cyclic climate model. The little bit of blue wiggles at the left end is the remnants of the Hadley data. Well, the cyclic climate model predicts that up until about 2060, the global temperatures are going to be about the same as they are today. There's going to be a wiggle up and a wiggle down and another wiggle up. But at the end of 2060, the temperatures will not probably be noticeably different than they are today. After 2060, the temperatures are going to rise again, and by about 2085, the global temperatures will be about 0.4 degrees warmer than today. And when we get all the way out to 2100, global temperatures are expected to be about 0.3 degrees warmer than today. You can see we're talking about very small numbers. All right, so these are the predictions of the cyclic climate model. How do those compare to the predictions of the consensus of scientists? The IPCC stands for Intergovernmental Panel on Climate Change. It's run by the United Nations. It issues reports occasionally describing the then current state of the climate. And the consensus of scientists are the largest contributors to those reports. So I'm kind of use IPCC and consensus of scientists synonymously. Well, the red line on this graph shows that this is the IPCC simulation for what they call their business as usual scenario. This means that the CO2 in the atmosphere is going to increase. We're not going to take any steps to reduce the amount of CO2 in the atmosphere. And because of population growth and the continued increase in the use of energy, the CO2 in the atmosphere is going to increase. And so the warming due to CO2 is also going to increase. So the IPCC business as usual scenario predicts that global temperatures in 2100 will be about 4.5 degrees warmer than they are today. But we just heard that the cyclic climate model predicts that global temperatures in 2100 will be only about 0.3 degrees warmer than today. Well, that's 15 times lower than the IPCC simulations. How could that be? How could that error possibly be? Well, the answer is in this dashed green line that I've added here. It's labeled 1.83 degrees centigrade per century. And what happens is all of the IPCC projections for all of their different CO2 scenarios, they all start off at current time with a slope of 1.83 degrees per century. And then they get worse, faster, or slower depending upon which CO2 scenario they're modeling. But for current time out to about 2020, they all have a slope of 1.83 degrees centigrade per century. So where did that number, 1.83 degrees centigrade per century, come from? Well, it came from curve fitting. The IPCC curve fit part of the Hadley data. This blue wiggling up and down line here is exactly the same Hadley data we've been talking about all along. The difference is that the IPCC climatologists chose to fit only the data from 1975 to 2005. And they chose to fit it with a simple linear trend because that's what they thought the effect of CO2 would be. Well, lo and behold, that linear trend matched to the portion of the Hadley data happens to coincidentally have a slope of 1.83 degrees centigrade per century. Exactly what the computer simulations show. So what's happened is that the IPCC has programmed their simulation of CO2 on planet Mythos to match this portion of the Hadley data for Earth, which are increasing. They actually are increasing at an average rate, if that's what you want to know, of 1.83 degrees centigrade per century. But in doing this, the IPCC has assumed that all the warming on Earth has been entirely due to CO2, because that's what it is on Mythos. The IPCC has grossly overestimated the effect of CO2 on Earth because of this, because they have ignored the existence of natural climate change on Earth. So what does this difference look like? The IPCC simulations on planet Mythos start in 1975 and continue upward at a rate of 1.83 degrees centigrade per century or higher. In the cyclic climate model, CO2 warming started in 1955 and continues upward at a rate of 0.37 degrees centigrade per century. That's what the data shows. There is no room in the data for 1.83 degrees centigrade per century. So by choosing the IPCC simulation, by using 1.83 degrees centigrade per century, they inflate the effect of CO2 warming by a factor of 5. Now this is a factor of 5 in the slope, the rate at which the temperatures are diverging. What that means is that right now, the temperatures that the IPCC simulation predict and the temperatures that the cyclic climate model predict are roughly the same. But as time goes by, the IPCC simulations are going to increase much, much faster, 5 times faster than the cyclic climate model would indicate, that the measured data would indicate. So as we get further and further into the future, the actual difference between the cyclic climate model temperature and the IPCC temperature is going to keep getting bigger and bigger and bigger. And that's how we ended up with a 15 times difference in 2100. Well, unfortunately, all of the IPCC's dire predictions are based on this 5x, 5 times inflation of the impact of CO2 on global warming. So if it may be possible to correct the IPCC CO2 predictions by dividing the slope of their curve by 5x. The red dashed line here is, again, the original IPCC prediction of future warming due to CO2 caused by their business as usual scenario. So if we take each of those data points along the curve and divide the slope by 5 and then reassemble a new curve, that turns out to be this green line here. So the green line is the corrected IPCC predictions of future warming due to CO2. I believe that this is what the IPCC simulations actually show. And unfortunately, what the IPCC simulations actually show is not nearly enough to justify their dire predictions of a coming climate catastrophe. And so they have, I believe, invoked a positive feedback mechanism in the Earth's climate that multiplies the actual effect of CO2 by 5 times. That's my own personal opinion. I don't have any hard knowledge of the true facts. So here we have then the corrected IPCC prediction for future warming due to CO2. This blue line is the CO2 component of the cyclic climate model, the 0.37 degrees. So it would be reasonable to assume that the actual effect of CO2 in future will be somewhere in the shaded region between the blue line and the green line, the corrected IPCC simulation. So let's make that assumption. Let's make the assumption that the CO2 component is going to lie someplace in that blue shaded region. The result is, now this is a plot of actual total predicted global temperature. This is not just the CO2 component. This is total predicted global temperature. And once again, the red dashed line is the original business as usual scenario from the IPCC. The green line is the cyclic climate model, but with the CO2 component of that model replaced by the corrected CO2 component from the IPCC simulations. And the blue dot here is the original cyclic climate model with a CO2 component of 0.37 degrees centigrade per century. So once again, it sounds like a very reasonable assumption is that the actual future temperatures will lie somewhere in the shaded region between these blue and green lines. All these predictions, you notice, are far below the IPCC simulations. Another thing to notice is that even assuming the IPCC's business as usual scenario corrected, the global temperatures in 2100 will not exceed 1.5 degrees centigrade. And that's very good news for the Earth's climate because the Paris Climate Agreement, it calls for putting a limit at 1.5 degrees centigrade. That's the goal that the Paris Climate Agreement is trying to achieve. Unfortunately, they think that the only way they can achieve that is by reducing the amount of CO2. What this analysis shows is that it's probably achievable by doing nothing. Well, that's a very quick or brief summary of the study. Much more detail in the book. Some of the conclusions are that global temperature data strongly suggests that the Earth's climate is being driven by natural cyclic processes. In the book, I analyze sea surface temperatures, and there's strong evidence in the sea surface temperatures that these natural cyclic processes are actually being driven by periodic variations in sea and the ocean temperatures, not by atmospheric processes. 80% of the global warming since 1850 has been due to these natural cyclic processes. 20% may be due to CO2. The IPCC has inflated the simulated warming due to CO2 by a factor of 5x. But even assuming the corrected values for the IPCC's business as usual scenario, global warming by 2100 will likely not exceed 1.5 degrees centigrade. This means that it's likely that the Paris Climate Agreement can be achieved by doing business as usual. Well, as I mentioned, there is a companion book. The title is the same, Inconvenient Data. The book contains a lot of extra information, including an analysis of sea surface temperature, as I said. It also includes an analysis of the weather. And more importantly, it describes how the cyclic, goes into much more detail on how the cyclic climate model was computed. It's available in both print and Kindle versions. So if this type of stuff really interests you, then just go and buy the book. Thanks.